when you isolate a trig ratio, you're not going to get root 2 over 2, or root 3 over 2, or root 3, or 1, or negative 1. Okay, so you're going to need to use your calculator. So non-exact. So you'll notice it says what to round to. If you're asked to give answers in radians, then it says to the nearest 100. Degrees, it says round to the nearest degree, which means whole number. Okay? So how are you going to tell? Remember, it's by the domain that's given to you. If it just says theta is an element of the set of reals, and there's no degrees translation or anything like that, then you have a choice. You can do it in degrees or radians. Okay? First one, pretty straightforward. This is back really to Math 10. You try to find the angle that gives you a sine ratio of negative 2/3. Okay, so this is where, in the introduction of trig, about a month ago when we started, we talked about where sine is positive or negative, so it's negative in third and fourth. And using our calculator, we would, what I do is find the reference angle. So in my calculator, I would go, so theta reference will be inverse sine of positive 2 over 3. Okay, so I'm dealing in radians. Mode key, radians, I'm good. Second, sine, 2 divided by 3. Okay, that is my reference angle. Remember, this gives me angles in the third and the fourth quadrant. So my theta will be pi plus this, and my other one will be 2 pi minus this. So theta equals, so here, actually, this equals 7. To show a couple of decimal places. In case I clear my calculator or something like that. But then my theta is going to be pi plus so it's in my calculator, just press plus pi, and then now round to the nearest 100, and then 2 pi minus, or back up, or copy out the value, and that's 5.55. Now, if we hadn't done the reference angle, so say I went second sine, negative 2 divided by 3. Notice how you get a negative angle. Can't write it down. Can't include it in your final solution set because I'm supposed to give angles between 0 and 2 pi. It has given you this angle here in the negative direction. So if you add 2 pi to that, then you'll get this. Okay? And then you still have to think about, okay, well that's negative, so then the reference would be the positive of it, and then add it to pi. So yeah, you can do that, but just be aware that it's not going to give you both angles, and it's not going to necessarily give you a positive. A question like that would just be really marking for the final answer. Next one, you have to do a little bit of work because you have to factor. Okay, so factor that because there's a cos squared, a cos, and a cos. then each factor is 0. We solve each of those for the Trig ratio. So, whose x equals 1, you don't need a calculator for that. Okay, and remember here, x is in degrees, between 0 and 360. So, when you get a cos of 1, you get it when x is 0. Notice how there's no equal sign there. So, I'm not going to use that, but I'm going to use 360, right? So, just 1. Okay, here is cos positive in the first and the fourth. Okay, 2/5. So something like that, right? So in our calculator, because that's a positive value cos, it's going to give you the reference angle. Okay, so second cos, I'm going to convert to degrees for this one. Second cos of, 2 divided by 5. So in your calculator, that's what it looks like. Okay, so we get, for degrees, it says nearest degree, so 66 degrees. That's that. Okay, then in the fourth quadrant, it would be 360 minus 66. Looks like a photo. So overall, it'll be 66. That's what, 294 and 360. Okay, so both of those were between for one rotation. Now the next two, C and D, are general solutions, all real numbers. Okay, folks, talk inside your brain to yourself. Okay, so C, 3 terms, you got squared, and stuff. How holding hands? What? Okay, get everything to one side, 0 on the other.
Oh, it doesn't like you. You did the blue line.
Yeah.
What is the blue line is grammar. What is the blue line?
And this is a grammar file, so it's something to do with it doesn't know what to do sometimes with not equations, right?
No, it's Trig, so it's like I don't know Trig.
Okay, so everything on one side and factor. Do not drop the equal 0. It's an equation. You need the equal sign. So one of these you'll need your calculator, the other one you don't need your calculator. Okay, so this says x element of reals, but we've said here radians. Okay, so I'm going to change my calculator back to radians. To get the reference angle, I just do inverse sine of 3/4. Because it's a positive angle, that's going to be your reference angle as well. I'm going to show a few decimal places because you know you have to deal with pi and it has decimals as well. So now your x for this, that will be your first one. Rounded is 0.85. In the second quadrant, it's going to be pi minus that. .29. Okay. Now we have to do the general solution. Okay. So the next set would be a complete rotation after that. This plus 2 pi. So you can do it, or remember that that's just go right to your general solution. 0.85 plus 2n pi, or 2 pi n, 2.29 plus 2n pi. I'm going to put a comma there because this I have to do a general solution as well, so that I can just write an element of the set of integers once. This one, that's a special angle, negative. So there and there. If you can give it as an exact value, do so. So that's going to be, the reference angle here is pi over 6. So here, we do x reference here is pi over 6. So x for this set is 7 pi over 6, 11 pi over 6, etc. So now Unfortunately, they're not equally spaced apart, right? So you can't just combine them like we talked about the other day. So I'm just going to say space go underneath here. 7 pi over 6 plus 2n pi and 11 pi over 6. 11 pi, where n is an integer. Four separate statements, lots in that case. Yeah, good, but if you can get them to be exact, then show it exact. I forget what, let me just see here. Yeah, it does say round all values to the nearest hundred, so we wouldn't mark it wrong in this question. But if we didn't specify, we sometimes say round to the nearest hundred where necessary. So in the second part of that, it's not necessary to round it because it is exact.
Yeah, I'd say that's a better, that's a better answer.
Okay, folks. Girls.
For the general statement, you say a equals 2n pi and then plus a to equal, or is that not allowed?
Never seen it. I guess if you put it in there, you could do that. But I haven't seen it written out yet. Okay, D, a little bit less complicated. You don't have to factor. You've just got two terms. One has the trig ratio, so isolated. It's squared, so take the square root of both sides once you've isolated it. And always, when you take the square root of both sides, you get a positive and a negative value. So don't forget about that. Okay, and then I prefer to convert it back to a primary trig ratio, tan, but you can leave it as cotan. Totally up to you. If I convert it back to tan, then I take the reciprocal. You can rationalize it, but there's no need. That's not your final answer. Okay? You're just going to enter that into your calculator, right? So the calculator doesn't care if it's rationalized or not. Tan is positive first and third, negative second and fourth. So every quadrant. So to get our reference angle, it's going to be inverse tan of positive 1 over root 5. This says general solutions in degrees. Get out a calculator. Check, make sure it's in degree mode. Okay, so then second tan. 1 divided by root 5. Okay, so that's going to be, and it says for degrees nearest degree, and you're not going to be adding any decimals to it. It's compared to 180, 360, etc. So you can round right now. Okay. So then what I like to do, before I do the general solution, I just do one rotation. So theta equals, so obviously 24 degrees. The reference is the angle in the first quadrant. Okay, then in the second quadrant, it's 180 minus 24. In the third quadrant, 180 plus 24, and the fourth quadrant, 360 minus 24. Okay, stop talking, you guys. So 180 minus 24 is what? 161.56. 204. 336, etc. And so our general statements is there, can we simplify this a little bit? Remember, period for tan is not 2 pi or 360, it's pi or 180. So these are directly across from each other. This plus 180 gets this one. This plus 180 gets this one. So I don't need 4 separate statements, because this is 10. I can do it in 2. And you can see there, you check this, plus 180 gives you 204. This plus 180 gives you 336. So 24 plus 180 n and 156 plus 180. Okay, take a look at question 2. It involves area of a triangle using your new formula, Trig. And then also remembering back to last year's Trig, where we talked about the ambiguous case.
This would be like a equation log. I don't think it's going to be.
Okay. Ambiguous case, don't need to groan about it. You've just done the ambiguous case basically every time you've calculated an angle. Right? You're checking for all the possible angles that give you that ratio. That's all you're doing. That's what the ambiguous case is. Okay? So, you're going to use this formula. C is the angle of the triangle between sides A and B, so it's the contained angle. So you can draw a diagram. It doesn't have to be to scale. It may not be exactly what it's going to look like. You don't know what the angle is, but let's call A 10.7, B 14.2. So here, this would be my A is 10.7, B equals 14.2, so C is here. And we're told the area is 40. So using our area formula, 40 equals 1/2 10.7 times 14.2 sine of angle C. So isolate sine of C. Now, if this doesn't work out nicely, which is going to give you a whole bunch of decimal places, I would actually just leave it as that fraction because this is not our final answer. So you can have a decimal in it within a fraction. Okay, it's positive. So now C, really they were finding the reference angle because it could be, we don't know yet, two possible cases. Okay, so second, what are we in? It says degrees, so let me check. Yeah, we're in the degrees here. So, second sine, 40 divided by 75.97. I'm going to just show a couple of decimal places to start. So there's my 33.77. Where is sine positive? Also in the second quadrant. So 31.77 or 180 minus that. Which is still less than, okay, now we should round it, right, to the nearest degree. Okay, so the diagram that I drew looks like this one with 32 degrees, right? Something like that. But 148, as long as it's not going to give you more than 180, right? So 148, that would look like, what would it look like? So if we have A here, and then B this way, right? Something like that, and that there. So this would be A equals 12.7, B equals 14.2, and this would be 148. Oh, should I do that in general? How can we get the third side? If you have this angle, then yeah, you can't even do sine law. Yeah. So two sides with a contained angle, always cosine law will give you the third side. Okay, so